You've probably always heard that cooking food makes it safer, right? I mean, it kills germs, makes it easier to digest, all that good stuff. But what if I told you that for millions of people out there with food allergies, the simple act of cooking could actually make a food, well, more dangerous? Yeah, you heard me right. Let's dive into the super counterintuitive world of food chemistry.
So, get this. Take the humble peanut. Researchers found something that is just wild. If you boil peanuts, their power to cause an allergic reaction actually goes down. Okay, makes sense. But if you roast them, which is how most of us eat them, their allergenicity actually goes up. We're talking about the exact same food here, but the way you cook it completely flips the script on how dangerous it is.
It just makes you wonder, right? How is that even possible? How can applying heat one way make a food safer, but applying it another way make it more of a threat? Well, the answer isn't really about the food as a whole. It's about something much, much smaller hiding inside. To solve this mystery, we've got to zoom way in. I mean, all the way down to the molecular level. Because the real story of food allergies isn't about peanuts or milk, it's the story of proteins and their incredibly complex little 3D shapes. Now, tons of foods can cause allergies, but it turns out over 90% of all food allergies boil down to just these 8 foods right here. People call them the Big 8. Just keep these in your back pocket because we're going to use them as examples to figure out what is really going on. And here is a huge piece of the puzzle. When your body has an allergic reaction, say to a peanut, it's not actually reacting to the whole peanut. No, your immune system is laser focused, targeting specific protein molecules inside that food. That's the real culprit. And you know what? It gets even more specific than that. Your immune system doesn't even see the entire protein. It recognizes and attacks a very particular section of that protein, a unique little sequence or shape called an epitope. Just think of it like the specific bullseye that your body's defenses are locking onto. Okay, now these little bullseyes, these epitopes, they come in 2 main types. And the difference between them? It is everything. On the left, you've got what's called a linear epitope. This is just based on the simple sequence of amino acids, kind of like beads on a string. But on the right, that's a conformational epitope. This target only exists because of the protein's specific, folded-up 3D shape. Think of it like a piece of origami. If you unfold that protein, that special shape is gone, and so is the target. And this one distinction, this is the key to our whole mystery. All right, let's keep going. Now that we know about these protein shapes, we can connect the dots to cooking. Because when you add heat or pressure to food, you are literally changing these tiny microscopic structures. So if we look at our diagram again, we can see exactly what happens. When you heat up a protein, it starts to unfold, or what scientists call denature. This process can completely wipe out those 3D shape-based conformational epitopes. Poof, they just vanish. But look at the linear one. Because it's just a simple sequence, it can totally survive the unfolding process. It's still there. This diagram of a milk protein gives us an even better look. So in its natural state, some of those epitopes are tucked away, totally hidden. With just a little bit of heat, say below 90 degrees Celsius, the protein unfolds, and this can actually expose more of those allergenic targets, making it more reactive. Crazy, right? But then if you really crank up the heat, above 90 degrees, the unfolded proteins all clump together into this tangled mess. And this can physically hide the epitopes all over again, making them basically invisible to your immune system. And all of this unfolding and clumping, has huge consequences inside your body. An unfolded protein might get digested differently, maybe presenting more targets to your immune cells and kicking off a bigger reaction. But a big clumped up protein might be too large to be absorbed properly, or its targets might be so hidden that the immune system just doesn't see them. It all comes down to that shape. But wait, there's a wild card, a real plot twist that happens with dry heat, like when you're roasting or baking. It's called the Maillard reaction. This is the amazing chemical reaction that gives roasted coffee and seared steaks that delicious brown color and flavor we love. But it's also a reaction between proteins and sugars that can create entirely new allergenic structures, what scientists are calling neoallergens. So here's the bombshell. Roasting doesn't just change the targets that are already there. It can actually build brand new, even more potent ones, completely from scratch. Okay, so let's put all this science together. What does this actually look like with real foods that we all eat every day? Let's check out the evidence. This table from the research really puts it all into perspective. Look at the peanut. Roasting with dry heat. That triggers the Maillard reaction we just talked about, and bam, it enhances its allergenicity. Now, look at cow's milk. Sterilization, which uses high-temp moist heat, causes all that clumping we saw. and that reduces its allergenicity. And then you've got the egg, whose main allergenic protein is so tough that even moist heat just leaves it completely unchanged. The researchers themselves said it best. Depending on the method you use, the allergenicity of a food can be increased, decreased, or just stay the same. You can start with the same ingredient and get 3 totally different outcomes. And that unaltered case with the egg is just fascinating. The reason a boiled egg can be just as allergenic as a raw one for some people is that its main allergen, a protein called ovomucoid, is basically a fortress. It's held together by these incredibly strong internal bonds that let it resist unfolding, even if you boil it for an hour. It's just built to survive the heat. So after all that complex chemistry, what's the simple takeaway here? What does this actually mean for how we should think about the food in our own kitchens? Okay, so what's the bottom line? Well, you definitely can't just make a blanket statement like cooking makes food less allergenic. It's way, way more nuanced than that. The effect of cooking is this complex dance between the specific food, the unique proteins inside it, and the exact method you use, whether it's moist heat, dry heat, pressure, you name it. So in the end, it really just boils down to these 3 possibilities. Processing can make things worse, like with roasted peanuts creating those new neoallergens. It can make things better, like how superheating milk can sometimes make it tolerable for allergic kids, or it can do pretty much nothing at all, like with those super stable proteins in eggs. And that leaves us with a pretty mind-blowing final thought. If we can understand these molecular tricks so precisely, how unfolding and clumping and chemical reactions change a food's danger level, does that mean we could one day use food processing not just for taste, but to intentionally program our food to be hypoallergenic? To literally engineer the allergies out? You know, the science suggests it just might be possible.